Good evening all. Today we are going to discuss the NumPy. After completion of the Python course, today we are going to discuss with the NumPy. NumPy in the sense num defines for numerical and py defines for Python. It is called as numerical Python. Okay, this is used for NumPy is used for numerical operations. NumPy is called as numerical Python. It is used for numerical operations. Okay, it completely deals about the numerical things which in the complete project. If you have anything to find, I will explain in the class regarding the NumPy. Okay, NumPy is a Python library. Another point is NumPy is a Python library. Let's discuss small things regarding the NumPy. Okay, but before discussing about the NumPy, we will discuss about the list. Okay, NumPy and list are of similar, but the difference between the NumPy and list is, see, first we will discuss about the list. List as able to store different types of data types in same list, right? Different types of data types, and second is of storing each item in random location in the memory. And third is of good for the scenario where list can grow dynamically, right? Where list can grow dynamically, we can give this as list can grow dynamically. And fourth thing was inbuilt, and it is a inbuilt data type. And fifth is of it has more inbuilt functions. It has more inbuilt functions. This is the complete of list, and list contains of different data types and storing each location in random location in the memory. Suppose if you're going to declare with the a equals to list of 1 2 3 4, it stores in the random location, not in the sequential location. And list can be dynamically, yes. It has more inbuilt function, yes, we know that. All, append, extend, these are the inbuilt functions that we have in the list. And while coming to the NumPy array, first thing is of it can store only one data type, only one data type, yes. Storing each item in sequential order in the memory. Array can store each item in the sequential order in the memory. And third is of, and this is also good for the scenario where the items are fixed size, yes. And here the thing is, need to install the library NumPy. Here we need to install the library NumPy, and here we don't require any extra functions, no extra functions. These are the difference between the list and the NumPy. I will give the difference between the list and the NumPy with a simple example. Here, see, this after this I will show a simple practical. Now let's give percentile time. See, a equals to list of range of 1 to, just give this command, and the wall time is of 998 mus, and the same thing import in the NumPy we can give as p np dot arrange of 1 to, yes, and we need to give here percentile time. See, see here you can have the difference here. Okay, we will give another 0 here. Yes, this is the thing, this is the main difference between the list and an arrange. See, list and the NumPy. In the interview also you can answer this question, what is the difference between the list and the, as we have the list, why you're going for the NumPys and all the stuff. And you can say that NumPy, it consists of single data type which stores the items in the sequential order in the memory. And the third point is of, this is the main point, if you use percentile time, here wall time is of 1 mu plus 0.3 mus, but here wall time is 0 nanoseconds, it is of nanosecond, is in milliseconds, and this is the difference. And this is how far better than this. See, if we run here also, see, it will take a lot of time to run. It was taking 997 milliseconds, but here it taking only 0 nanoseconds. This is far better than the list. This is the basic example that I'm going to teach you, so I was not printed this. Okay, if I print it, this gives the answer. If I zoom out and if I show you the stuff, it's of, see, wall time is of 3.41 milliseconds. Here wall time is of 0 nanoseconds. This is the difference between the list and the NumPy. Okay, array is fast, then at last we can conclude this. Array is faster than list because less memory taken, because less memory was taken. And now we are going to the NumPy, right? Array contains of single dimension, multiple dimensions, 1D, 2D and 3D arrays. There are different types of 1D, 2D, 3D, 4D, 5D. These are the different types of arrays that we have in the NumPy. Okay, and the difference between the 1D array contains of only rows. I will explain with the practical, and this is the theoretical concept that I am going to explain you right now. And 2D contains of rows and columns, as well as 3D contains of layer, rows, columns. These are the things which the array consists of. And before going to the NumPy, and we need to install the, as I said that we need to install the NumPy, right? Then we need to go for pip install NumPy. So if you give this command, it will install NumPy. See, this was the, it will take some time to install. Already I had the NumPy installation in my Jupyter notebook. And next command is of let's the time it can be taken, import. Yeah, requirement already satisfied. And now we can write as import NumPy as NP, as in the sense it is of nickname of NumPy. We can write as in the shortcut of NP. Here you can write your name also, no issues. Import NumPy as NP. Here NP contains of complete NumPy thing. Okay. Now let's define a NumPy array passing a list with 1, 2, 3. That's it. Equal to NP dot array of 1, 2, 3. Okay, this is the array of 1, 2, 3. This is the NumPy contents of list with 1, 2, 3. Okay, and to know the main thing is to know the how many dimensions that NumPy has. Okay, let's take equal to NP dot array of 2. If I run this code, if I print a, it says 2. It consists of array of 2. Now to check the dimension of the array, check the dimension of the, which type of dimension is this? To check this, we have print a dot n dim. Okay, this gives this is the 0 dimension that we contains of, and we can check the shape also. Print to check the shape. Here print a dot shape. That's it. It's of no shape that we have, and at the last you can check. You can also check the data type. Data type print a dot data type. It is of int. The same thing consists of the 1D array, 2D and the 3D array. Let's take this, and we will declare with the b. Here the prints consists of the b and array of 2, and this is of 2, and we are going to check the which type of dimension is this. We will check all at a time, and we will also check the shape, and we also check the data type. And here we need to give b, because in the variable b we have, see, it is of one dimension, and its shape is of 1 comma. I will explain this thing, and its data type is of int, as well as in the np dot array of 2D. Let's take c equal to np dot array of, for 2D we need to give 2 brackets. Okay, one, again another 1 bracket, 1, 2, 3, and close, again 1, 2, 3, close. That's it. Print C. Now here shape is nothing but, here we contains of 2 rows, 1, 2 and 3 columns. 2 by 3 is the shape of this. Okay, let's copy this and let's paste here and give here the variable as C, and I think you got with the shape 2 by 3, 1, 2, 1, 2, 3. 2 by 3 is the shape, and the data type is int, and in dimension is it is a 2D array, as well as we contains of 3D array. Copy, we will copy here and we will paste, and let's give as D, and here it contains of another bracket. Okay, and in which it consists of this stuff, and this is of 3D array, and let's copy this and let's paste here and we give as D. It is of, in dimension is of 3D, and its shape of 1 2 3. Index is of 1. From here it is going to start 1 and 2 rows and 3 columns. This is the shape of it, and it is of integer data type. This is the thing that we need to remember to know how many dimensions it consists of, and to check the dimension of the array, to know the shape of the array, to know the data type of the array. These are the main important things in the NumPy we need to remember. Okay, and the first main thing is, what is the difference between the list and the array? This is if you are going to write percentile time, that you within the time seconds you can understand it is of 3.141 milliseconds, but here it is of 0 nanoseconds. This is the how speed is of NumPy, we can say that. And these are the different stuff that we contains in the NumPy. And see, in NumPy, let's create a array using arrange function. Let's use here. Let's create a NumPy arrange with 1 to 11. We can create up to 11. That's it. We can write as np dot arrange of 1 to 11. That's it. Sorry, we need to give the brackets. Module NumPy arrange we need to take this. See, this is the thing. Arrange, the spelling is wrong. np dot arrange of 1 to 11. It gives in the form of list only. Already we don't need to give here the list things. It is in the form of array of 1 to 10. The 11th term will be excluded. And see, as we know, in the list also we contains of slicing, and in the NumPy also we have with the slicing part, like np dot arrange of one to 11 comma 2 start stop step. It contains of 1 3 5 7 9. That's it here also. And let's discuss some important functions in NumPy. First thing is of I function. I function means, see, I in the form of identity function. See, diagonally that we can print the matrix. See, np dot I of 5, and we need to give the data type of is int. That's it. Close this. And this is of the I function in the NumPy. You need to remember. Next is of 0 function. These are the functions in the NumPy we need to remember. np dot 0 of 3 by 5 matrix, comma, data type is int. Again we go out with zeros. We need to give here zeros, guys. Okay, it is not 0, it is of zeros function, and we having with ones function. Ones function is of np dot ones of 3 comma 3 by 2 matrix. That's it. You can give this. It by default it gives in the form of, if you don't give the data type, it gives by default, it takes in the form of float only. Output in the form of float. Okay, and again we are having with full function. What is full function in NumPy? np dot full of 3 by 2 matrix, comma, with 10. See here, 3 rows 2 columns, 3 by 2 in the sense this, and you should fill with the number 10. This is the code for the full function. See, to change the identity matrix, to change the list into identity matrix, we are having one function called diagonal. So let's take x equals to list of 1 comma 2 comma 3 comma 4 comma 5 np dot diag of x. See, it converts the list into the diagonal matrix, and this is the specialty of the NumPy within the NP in the sense NumPy within the single code that we are converting into full function, zeros function, diagonal function, zeros function, I function. See, within the code np dot arrange you are going to create, but in the list that we need to write each and everything. And this is the specialty of the NumPy, which is far better, which is the fastest than the list. So we are going to use this, and now we are going to use with random number. Here random number in the sense a number will be randomly generated. See, for OTPs and all the stuff, from here on the random numbers will be generated. Random dot random of 1. See, this is the random number which is going to generate it, and I will explain you in the random also. If I take here not only 1, if I take 5, I'm going to, it will generate 5 random numbers within the series of 0, 0. If I use it to take, if I need only first, so we need to give brackets of 0. This is the simple random number. And for random, if you are not getting, you need to do is import random in your laptop. That's it. It will import random, and we are going to have the another numbers also, randint, in the form of integer. Random dot randint between 100 to 200. Let's see. Yeah. See, within the number 100 to 200 is a number is generated. It is of randint. Okay, import random dot random. This is the thing. And another one concept is of reshape concept in NumPy. I will explain you the where NumPy we will use, and in the last of the video I will explain you the stuff actually where the NumPy is used. And actually I'm going to explain this is the stuff that we can do with the NumPy, but actually in the projects and where the NumPy actually the part is takes place, and only one place, not only one place, in some places we use the NumPy, but I will explain you all the stuff. And NumPy reshape concept in NumPy is changing the shape of layer, rows and columns. That's it. Changing the shape of rows and columns, layers is of reshape, shaping into the another shape, like let's take an example. Okay, x equals to np dot range of 1 to 10. Okay, print x, give the print x, and you need to check the print x dot shape. We're changing the shape into reshape. That's it. Print x dot in dimensions. We need to check the dimension also. It is of a range of 1 to 9, and then there is the excluded, and the shape is of 9 comma, because, and this is the shape of 9, and the dimension is of 1D and 1 2 3 4 5 6 9 comma something and we are going to reshape this like n equals to, in the x we have the array, right? X dot reshape of, I'm converting into 4 by 4 matrix. Okay, let's take up to 17. Okay, and here n equals to x dot reshape in the 4 by 4 matrix, print n. That's it. See, this is the function of the reshape, which is changing one shape to another shape, is called as reshape, and according to our matrix we are going to reshaping it. And the next is of travel function. Travel function is of like undo, control plus z that we contains in the keyboard. This is the undo function. If you do any ravel things, it can be undo v equal to n dot, just now we done with the reshape, right? We are going to ravel that, n dot ravel, that's it. Print, if we give v, it was converted another into the, it is of ravel means control z. This is the specialty of the ravel function. And flatten function, converting multiple dimension to one dimension. This is the specialty, is converting multiple dimension to one dimension. Okay, x dot flatten, if you give this thing, it converts, it directly converts, see, x multiple dimension to, when if you want to convert the multiple dimension one dimension, we can use this flatten direct function. It is of ravel, is of control z. Okay, NumPy will support random and slicing, as we know that. And this is the part in the NumPy. And again another is of transposing array. This is the converting rows to columns and columns to transpose. Converting rows to columns and columns to rows. This is the specialty of the transpose. That's it. Just you can give us print a dot, if we have n, n was converted into this, right? Let's take what is a here, let's do with d, print d dot transpose. That's it, converting rows into columns and columns into 1 1 2 2 3 3. Let's see here what is d here. See, this is a d, 1 1 2 2 3 3. These are the columns and these are the rows, right? Which is, it is a converting rows to columns and columns to rows. This is the main thing. And another function we are having with horizontal stack and vertical stack. This is of horizontal stack and vertical stack. And let's take a comma b equals to of 1 comma 2 comma 3, close with and open with 4 comma 5 comma 6. This is of 2D array, right? Not with 2D array. And a comma b consists of that, this thing, right? np dot h stack of a comma b. See, horizontal stacks means a comma b consists of 1 2 3 4 commas 4 5 6. If we convert the both things into np dot h stack in the sense horizontal stack means converting the arrays into the horizontal, which is of appending, and vertical in the sense which converts into vertical B stack also. It is of vertical stack. A consists of 1, 2, 3, and B consists of 4, 5, 6. See, just give np dot b stack of a comma b. That's it. See, this is of a, this is of a, and this is of b, and which converts into the vertical stack. This is of, it is of 2D array. This is of 2D to 1D, which converts into horizontal stack. This converts into the vertical stack. That's it. And again we are going to have the insert function. Insert function is of, like, if you like to add the particular position a element, we use the insert function. Let's take np dot insert of a comma 4 comma b. This gives the error. Index 4 is out of point of axis with size 3. Let's give 1. See, 1 4 5 6 2 3. This is the this consists of a consists of 1 2 3, right? 1 2 3, and within the, see, this is the 0 position, this is 1, and this is the second position. Within the insert function, within the 1 position, it is 4 5 6 has been added, and next the 2 3 has been. If you give 2 here, let's try to understand. 1 2 4 5 6 and 3. See, a 2 b in the sense, see, first a contains of 1 2 3 and b consists of 4 5 6. Don't see this, see this. A consists of 1 2 3, 4 consists of 4 5 6, and we are going to insert a comma, a is of 1 2. After 2 we are going to insert b. Okay, a, after 2 we are going to insert b. 1 2 4 5 6, then 3. If you are going here 3, if you run this, now see, after 3 we are going to insert b. See, after, if you give here 1, after 1 we are going to insert b. See, 1 4 5 6. This is the insert function. This is the specialty insert function we need to understand. Okay, see, now I am going to discuss the important NumPy where we use. From here we are going to important the NumPy. See, if you are having with the list of np dot arrange of, let's take 1 to 10, print. Yeah. This is of thing, right? See, np dot median of a, np dot mean of a. See, np dot std standard deviation of a, np dot max of a. I will explain you the where we use the this np dot sort of a. Okay, this is the NumPy where we use. And first we are going to we have arrange function between the 1 to 10, and then there is the excluded up to 1 to 9. And see, actually NumPy is used in the statistical format is of mean, median, mode, standard deviation, variance, skew, kurtosis, and within the different mathematical operations. This NumPy is used within the fraction of seconds. It is going to calculate the median, mean, standard. See, if the row consists of not only up to 10, with up to the 1 lakh rows, and for this 1 lakh rows you need the median. So at this position that NumPy is used, we need the median. At this position the numpy is used. And while going in the depth of the concept, that we contains of outliers in the sense, suppose if you are going to have the example of 1 comma 2 comma 3 comma 4 comma 5 comma 6 comma 7 comma 20 comma 21 comma 22, here the outliers are 20, 21, 22 because which are away from the numbers of within the series of 1 to 7. For these outliers we need to remove. Suppose if we are going to calculate the mean of these, this will be vary because the 1 to up to 7 will be different, and 20, 21, 22 it will gives the huge number. But we are going to take in the median of the number. It consists of the complete this concept is of complete missing values in the data set. It is of the complete different era. For there we are going to use this numpy for to know the mean, to know the median, to know the mode. For this type of operations that numpy is going to use. This is the main concept that numpy is going to use in the data. As a data analyst we are going to using there. And for finding the maximum, see, the data set consists of up to 5 lakhs 10 lakhs of rows of data, right? For this to calculate the all the mean, median, mode, we need to have, so within the list and all the stuff we are not going to calculate within the time, but with the numpy within the fraction of seconds that we are going to calculate what is the mean, what is the median, what is the mode. Here numpy is used, and these are the different types of functions that the numpy consists of, and this is of additionally. So this mean, median, mode, standard deviation, max, sort, and sum, these are the different types. So here the numpy is used. These are the basics of the numpy. So I think you have understood this concept. Okay, you are okay with the numpy. You don't no need of any other stuff. I think this is the enough for that. As a data analyst, it is enough for you about regarding this numpy. These are the different functions that we can use of, but we don't use any functions. Only we use with the mean, median, mode. Oh, these three operations, and with the different operations also like standard deviation, skew, kurtosis, and variance. Again we are in the data set. If we condense of the missing values, to fill the missing values we use this type of numpy operations. So numpy in the sense it is of numerical Python, and so this is of complete numpy, guys. This is of basics of the numpy, you can call it as, and which is the most faster than the list, we can say it. And we are going to, and this is of complete numpy. Thank you.